Hello students, in the previous video we have seen how to insert n arithmetic means between two given numbers, and in this video we are going to discuss an important result using arithmetic progression, that is the sum of n natural numbers. So if you are taking the sum of n natural numbers starting from 1, then it will be 1 plus 2 plus 3 plus 4 plus so on up to n. Now here we can see that the terms have a common difference equal to 1. So you can say that they are in AP. So this will be equal to sum of terms in AP with first term equal to 1 and common difference equal to 1. So when we apply the formula of sum of n terms, sum will be equal to number of terms by 2 into 2 times the first term plus n minus 1 into d, or this can also be told as n by 2 into sum of the first term plus sum of the nth term. So we can use either the first formula or the second one. So I'm going to use the second formula here because we know the last term is n. So this will become n by 2 into the first term is 1 plus the last term is n. So this will become n into n plus 1 by 2. Now if suppose we are going to use the first formula. So when we use the first formula, it will be n by 2 into 2 times the first term is 1 plus n minus 1 into the common difference is also 1. So this will become n by 2 into 2 plus n minus 1. That will be equal to n by 2 into n plus 1. So using the first formula also we got the same thing, n into n plus 1 by 2. So from this we can say that sum of first n natural numbers equal to n into n plus 1 by 2. Now let's see one more case in which the first term is not equal to 1. So suppose it is starting from 4. Then this will be 4 plus 5 plus 6 plus so on up to n minus 1 plus n. So I'm not taking n terms, but I'm taking that the last term is equal to n. So we need to first find what is the number of terms. So the nth term will be equal to a1 plus number of terms is take capital N minus 1 into common difference is d. When we are taking consecutive natural numbers, the common difference will be equal to 1. So when you substitute 1 in this, then we'll have the nth term is n equal to the first term is 4 plus capital N minus 1 into 1. Then we have n minus 4 equal to capital N minus 1. Then we'll have capital N equal to n minus 3. Now the sum will be equal to number of terms by 2 into the first term plus the last term. Since we know the last term, I'm using this formula. So that will be equal to n minus 3 by 2 into the first term is 4 plus the last term is n. So this will be equal to n plus 4 into n minus 3 by 2. Now let's see one more case in which again we are going to start from 4 plus 5 plus 6 plus so on up to here. Instead of taking the last term as n, I am going to consider that the number of terms is n terms. So we don't know the last term, but we know the first term and we know the number of terms. Then we can use this formula that the sum will be equal to number of terms by 2 into 2 times the first term plus n minus 1 into d. So here you need to note that in the previous case this is the nth term, but in this case this is n terms. So this is the number of terms, and here the n will be the nth term, this one, and here n will be the number of terms. So this will be equal to n by 2 into the first term is 4, so this will be 2 into 4 plus n minus 1 into the common difference is again 1 because we are simply taking the consecutive natural numbers into 1. So this will become n by 2 into 2 4s are 8 plus n minus 1. Now in this case we'll have n by 2 into So this will become 7 plus n. That means it is n into n plus 7 by 2. So instead of starting with the constant number, in the previous cases, we have seen that we have taken 4 as the first term, but now I'm going to consider simply as a, and I'm going to take that from a, we are going to consider n natural numbers, or from a, we are going to take that the last number is n. So let me take the first case. The first case is I am starting from n. It will be a comma a plus 1 comma a plus 2 comma so on up to n minus 1 and n. So this is the last term, n is the last term. So in this case, we can use a sum equal to number of terms by 2 into the first term plus the last term. So first we need to find the number of terms. So to find the number of terms, we can use that an equal to a1 plus n minus 1 into d. So when we solve this, we'll have n equal to a plus capital N minus 1. Since d equal to 1, we can directly write it as n minus 1. Then we'll have n minus a plus 1 equal to capital N. Now substitute this in the formula. Then we'll have n plus 1 minus a by 2 into a1 is a plus the nth term is n. So from this we can tell it will become n plus 1 minus a into n plus a by 2. So this will be the formula for the case in which we have the first term a and the last term as n when consecutive natural numbers are taken. Now let's see the second case in which the first number is a plus 1, a plus 2, comma so on up to here. Instead of taking the nth term, I'm going to take that there are n terms. Now in this case, the sum will become number of terms by 2 into 2 times a1 plus n minus 1 into the common difference, which will be equal to n by 2 into the first term is a, so this will be 2a plus, since the common difference is equal to 1, we will have n minus 1. So this will become n into 2a minus 1 plus n by 2. Now here you can check whether this formula is true or not by substituting 4, because we have done the case in which a equal to 4. Now let's check. When a equal to 4, we'll have n plus 1 minus 4 into n plus 4 by 2. Then this will become n minus 3 into n plus 4 by 2. So here you can see that this is n plus 4 into n minus 3 by 2, which is also the same as n plus 4 into n minus 3 by 2. That means it is true. Now let's check for the second one. When a equal to 4, we'll have n into 2 into a is 2 into 4 minus 1 plus n by 2. That will become n into 2 into 4 is 8 minus 1 plus n by 2. So this will become n into n plus 7 by 2. Now let's check whether this is true or not. So you can see it is n into n plus 7 by 2. Here also it is n into n plus 7 by 2, which means this is also true. So these are the results that we can obtain by considering the consecutive natural numbers as a mathematical progression. Hope you understood well. Thank you.